Good afternoon to all of you. Hope I am completely audible and visible to all of you. Kindly give me a response so that I can start the session. I am waiting for your responses. That am I audible and visible to all of you? After your confirmation, I will start my session. I am waiting for your responses. Kindly give me a single responses in my WhatsApp number, please. So that I can start. Any one of you, please give me a response. Am I audible and visible to all of you? Those who are viewing, those who are online, kindly give your response, please. Those who are viewing, kindly put your responses, please, so that I can start. I am waiting for your responses. Those who are viewing, kindly put your responses so that I can start. Those who are viewing, kindly put your response. Okay, now I am starting. So, in last session, we already discussed about the indexing concept. Okay, so before that we already discussed about the file handling concept. In file handling concept, we already discussed about the fixed length file structure and the variable length file structure as well. Okay, so the file handling, the fixed length and the variable length file structure is quite important for our database management system. Okay, so now we are going to discuss about the indexes. Okay, in last session we already discussed some basics about the indexes. Indexes is quite helpful in database management system to search any values in a pre-existing databases. Okay, so some topics are quite related in our indexing part. First one is obviously the basic concepts and the order indexes concept, then B tree, B plus tree concept. Some small portion of hashing is there and some multi-level indexing concept and some other kind of indexing concepts are there. So I hope that Srilekha ma'am already discussed lots of topic related to the indexing and B tree and B plus tree. So this part, B tree, B plus tree and the example part will be covered by the Srilekha ma'am in Wednesday class. Okay, so for today, I think today is my last class in this database management system. Okay, tomorrow classes will be taken by Momita ma'am. Okay, so today is the last classes for database management system, and very simple and last topic is pending here, that is the indexes. So first we are starting with the indexing concept. Indexing is basically useful when we are searching an element from a large database or from a large record. I already explained that thing, but for your beneficiary I am explaining it once again, that from a library, when you visit a library, that from when you are asking for a particular book, the book may be searched by a particular key values. Okay, so when you are visiting a library, first you are asking for that I need a book from the Department of Computer Science and Engineering. So you are redirect to a particular book rack or redirect to a particular almirah. Okay. Next, in this particular rack or in this particular almirah, you are searching books for different subjects. For example, in first rack, there may be availed with the book of database management system. In second rack, there probably hold the books of operating system. In third rack, probably there hold the books of computer network, like that. So whenever you are searching for the database management, so in the computer science engineering almirah, you are searching for a particular subsection or a rack, and after that, depending on a search key values or depending on a identity values, you are finding the books that may be depend on the author name. If you are searching the books by the author name in alphabetical order, then it is considered as the author name can be considered as the index key. And if you are searching the book by a particular ID number like the ISBN number, then the ISBN is considering as the index key for this searching. And if you are considering by the whole title of the book, then maybe the title can be considered as an indexing of key. Okay, so here the concept is that what is index key and why it is important. Index key is basically is a kind of a search key, and using this key you can search an element from a large database. Okay, so now we are looking to the search key. Search key is considered as an attribute of the whole records. Meaning is that if you are considering for a book, a book maybe contains some required information like the book title name, like the book author name, like the book ISBN number, like the book domain name, like the book publishing year, like the publishing house name. This kind of information should be present in your database. Okay, for each and every single book, you are maintaining a single record row by row in a database. Okay, so what is the search key? Search key may be considered like that for a particular record, for a particular or any specific record. If you are taking a particular attributes or fields as your searching option, then it is considered as the search key. Means from the record, if you consider that thing that ISBN number is considered as the search key, it may be possible. If you are considering that the book title can be considered as a search key, that can be also a possible things. Okay, so when you are maintaining this kind of a records or this kind of information, then it is considered as a database. So from this database, if you have copied only the ISBN column from a database or from a library database, if you only copied the ISBN number column and paste it in some different file, then this particular file only handling the information that related to your indexing. Okay, means all the index related information are present in this databases. That is considered as the index file. So index file can be considered as a separate file from the main database, and in this index file only the attributes or only the search key information is present. Okay, so here in the index file, whatever you are considering, that may be considered as a search key or index entries, whatever, that index entries can be divided in two parts. Means in your index file you have to store two column or you have to store two information. First one should be your index entries, means the book ISBN number or the search key, and second one is your the pointer values. Means for example, your first book ISBN number is for example ABCD, and this particular ABCD book information should be present in the main database in the row number 567. So here ABCD is considered as the search key for the main database, and the 567 row number is considered as the pointer to link up the search key to the main database. Got my point? So in index file is a same kind of a thing like your book index, that in your book index you are maintaining some topic name as well as you are maintaining some page number. So here the topic name can be considered as the search key and the page number can be considered as the pointer. Means in this particular page you may got this information regarding this particular topic. So same thing is here in your index file, whatever index entries are present with you, two option is there, or sorry, two fields are there. First one should be your search key and second one should be your pointer information. Okay. So index file is obviously generally quite smaller than the original file, means index file size is obviously quite less in comparative to the original database file. So in comparative to the books content file, the index file size is quite lesser. Okay, so total two type of indexing we are maintaining. First one is the order indexes. Order indexes is a similar kind of indexes like the book index, means the topic information is present in the book. The topic information is present in the book according to the page number, and this page number should be in a sequential order. Means for example, in your database, if the basic information is present in the page number 1 or in module number 1, then the ER diagram concept is present in the page number 2 or in the module number 2. Okay, so the things are quite similar here, that first one in your indexes, first one should be your order indexes. So in order indexes, you may consider that thing, that all the search key values and as well as the related pointer information, in maximum cases that should be in a sorted order. At least search key value should be in a sorted order, or the page number or the pointer value should be in a sorted order. That is the scenario. Another scenario is that in our real life, our database size is quite vast. So every time maintaining the sorted order in the search key values or in the order indexes, that is not possible. So what is the technique? The technique is that for the better security or for the better consideration, or to fetch the data from a large amount of databases, we are planning for a different kind of a mechanism, that we are designing a certain hash function, and depending on this hash function, the hash function generate a particular search key values, and this search key value is related to the particular records in the main file. So here we need a kind of a hash algorithm. Hash algorithm is a kind of a thing, for example, that whatever number I am giving you some number, that 5, 6, 7, 8, 9, 10. So your task is that compute this number by modulo 3, means 5 modulo 3, remainder is 2, 6 modulo 3, remainder is 0, 7 modulo 3, remainder is 1, like that. Okay, meaning is that depend on a particular hash algorithm, we are generating the search key in some randomized order, and this particular in randomization order, we are fetching the particular records from a large database. So why we are using the hash function, or why you are using the hash indexes? Hash indexes is quite helpful for the large database, and as well as the hash index also provides some security concepts in our existing concepts. Okay, that is the main benefit of the hash indexes. We already covered these things. Next is that the index, which type of indexing, means the order indexes or the hash indexes. Which type of indexing is more useful in our cases? For that purpose, we are taking care of help for some of the matrices like the access time, insertion time, deletion time, space overhead, this kind of a thing. Access time means the searching time, insertion time to add a new search key, deletion time to delete a search key, and space overhead, how many storage it's allocated. Okay, so you already covered these things. Now we are focusing on some order indexing concept. In order indexing concept, there are basically 3-4 type of indexing concept is there. First one is the order indexing concept. In order indexing concept, entries are sorted in order. So in order indexing concept, there are 2-3 types are there. First one is the clustering indexes, and second one is the secondary indexes, and next one is the index sequential file. So in clustering indexes, in a sequentially ordered file, the index whose search key specify the sequential order of the file. Means in your order indexes, if all the things are maintaining in some sequential order, means all the search keys are maintaining the things in some sequential order, that can be considered as the clustering indexes, or sometimes it can be considered as the primary index as well. Okay, so the search key can be considered as the primary indexes. Maximum time it's possible, but in some cases you may avoid that thing. So now what is the secondary indexes? Secondary indexes, sometime it can be considered as the non-clustering indexes. Non-clustering indexes is a kind of a thing where an index whose search key is specify an order that different from the sequential order. Got my point? Meaning is that in sequential order, you are maintaining the search keys in some particular sorted order. That may be ascending or that may be in a descending order. But in secondary cases of indexes, there is no need of any kind of sorting, but the sequential order should be followed. That is considered as the non-clustering indexes. So apart from these two things, there are some index sequential file concept is there. Index sequential file concept meaning is that, for example, sequential file that should be ordered on a search key with the clustering indexes of the search key. Okay, meaning is that depend on the clustering index, you are maintaining a search sequential file. That file can be considered as the index sequential file. Now you are focused on the example. So here for the order indexes, the first example is for the dense index files. Here you can check that thing that all the search key information are here in the left side column, and all this search key information are already in ascending order. Okay, this information are already in ascending order starting from the 10101. So here the index file, the left side file is considered as the index file. In this index file, two information is there. First one is considered as the search key, and second one is here pointer information. And this particular pointer is linked to the specific search key that is present in our index file. Okay, so here the index ID is related to the instructor relation depending on the search key. Okay, that is the ID number of the employees. So here directly they are maintaining the link, means each of the search key are maintaining the link with the record with the similar search key. Okay, and the situation is indexing, and the situation is sequential in order. That's why it's connected to each other, means the first record is connected to the next one is connected to the next as well as the previous, and the same order is maintained here. Okay, so meaning is that if you delete a particular record, if you delete a particular search key from the index file, as well as you have to delete the same records from the databases, and the order should be maintained accordingly. So these are the dense index example. Next example is that is also a dense index example. So here the same thing is maintained, but the scenario is quite different. Scenario is different, meaning is that here the things is that first here you are maintaining the indexes that is depend on the department name in alphabetical order. Got my point? Here in the index file you are storing the information. Two information you are storing. First one is your department name, and next one is obviously your pointer that is linked, and next one is your databases. So here you can check that thing. In your databases, all the records are maintained in some haphazard order. Haphazard order meaning is that all the records are mixing. It's not according to the employee ID. So here the employee ID is starting from the 76766, and the next employee ID is starting with the 10101. Okay, so here the order is not properly maintained, but if you look into the department table or in the department column, you can check that thing that is properly in a alphabetical order, that is starting from the biology, computer science, then electrical information record, then the finance information is there, next one is the history, next one is the music, next one is the physics. So here the scenario is that the particular index file is related with this instructor file that is depend on to the index entries subject information. But here the similar thing is that all the entries are here connected by each other according to the laws of the sequential indexing. Okay, so here where the biology meets the exact match with the department, they get the result, and same as for the computer science. So some of the people may ask for that, sir, for the computer science there are total 3 entries, how you can connect these things. So here we are connected depends on this particular mechanisms, depend on the pointer values. Okay, if the pointer located to the different department, you may go to the different department, that is as per your choices. Okay, so here basically it's understand that whenever you are finding the values using the computer science, initially the computer science locate the first entry of the computer science, and after that the rest of the entries of the computer science are present. Means here using this sequential search, Using this sequential search, first you find the department actual location or the department first entries in the whole database, and after that using the sequential search or using the sequential linking you can get the information. Okay, so same as for the electrical engineering, same as for the finance. First you get the finance for the ID number 12121 and this information is related with the next, like that. Okay, so that is also an example of the dense indexes. Two scenarios is there. One is depend on the employee ID, another one is depend on the branch information. So next in example of the sparse index. So dense and sparse, when we are thinking about the dense means it's compacted, and when we are thinking about that sparse indexes, meaning is that here the sparse indexes means is that the things are quite distributed. Okay, so in sparse index contains index records for only some search key values, means for the exact search. Means here maybe each of the records are connected by the sequential mechanisms, but here the things is like that we are want to find the exact finding or the exact match. Okay, contain index records for only some search key values. Okay, so this scenario is applicable when the records are sequentially ordered on a search key. Okay, so sparse index is also a type of a ordered index. Why it is called say ordered index? Because all the values, all the search key values in the database, all the search key values in the database, not an index file, all the search key values in the database that should be present in some specific order, maybe in ascending, maybe in descending. Okay, now how can you initiate your search? Initiate your search like that to locate a record with the search key value k. Means from the index file, if you are getting a search key value k, how you can look at that thing? Find the index record with the largest search key values that should be less than k. Means for the first, if you are starting with, for example, if you are starting with 32343, so your target is that you find the last record or the largest record, but the record should be less than the value k, meaning is that you are finding the record up to 32342, not 32343. Up to 34342 you are finding the records, and after that you are connect with the some sequential mechanism. So search file sequentially starting the record to which the index record the point, and after that you will get it automatically. That is the sparse index. It is quite distributed. Next one is that the comparison. Which one is quite good, sparse index or the dense index? So in compared to dense index, the sparse index obviously requires some lesser field. Means whatever information or whatever information you are seeking, you need to store only this particular search keys, and obviously some less maintenance overhead is there. Means in case of any changes in the order, that should not affect so much. Okay, but in case of a dense indexes, they are required so many overheads for the maintenance purposes as well. So generally sparse index is quite slower than the dense index, because in case of a dense index all the values are got one by one in some searching order, but in case of a dense index the file may be distributed. Okay, so the good concept is that, for example, for clustered index, sparse index with an index entry for every block in the file corresponding to least search key value in the block, meaning is that for which one is beneficiary in compared to the dense and the sparse. Sparse is quite beneficiary, because in case of sparse index, where the index entries are there and the related pointer information is there, and using this pointer information you are finding the search key easily from your data block. Okay, that is case of a clustered index. But in case of a unclustered index, sparse index on top of dense index. Okay, so next is a concept of the secondary indexing concept, means the non-clustering indexing concept, or you may consider as the secondary indexing concept. So here the concept is quite typical, meaning is that one databases are there and some your primary indexes are there. In your primary indexes some values are there in some sorted order, and for example in your primary indexes the salary information is there, it is in a sorted order, and in your databases the database is already sorted, that is depend on the records values or the records ID, that is starting with 10101, 12121, like that. Now you are thinking, sir, in primary indexes we are thinking about that we should go ahead with the salary information, and as well as, but in case of a databases, the information is already stored, or the information is already sorted with the help of the ID number only. Here the salary is distributed, means the salary is sparse, ID is dense, and here the salary is dense. How we can connect? So for this connectivity we need some another indexes that is considered as the secondary indexes. In secondary indexes, how it is that, for example, that salary is 40,000, and this particular, which salary is 40,000, this particular pointer is connected to the link of this particular ID number whose salary is 40,000. Meaning is that here the list is maintained with the salary information, and here the list is maintained with the ID information. So here we need one intermediary to find that whose person's salary is 40,000, and here we have to find that whose person ID is particular in respect to the salary 40,000. So here two things is matching here, the salary and as well as the ID information. So that is considered as the secondary indexes. Okay, that is considered as the secondary indexes. So whenever we have connected that 40,000, the 40,000 is connected with a single block only, means only one record is present here. As well as if you are looking into the salary 80,000, in 80,000 here you can check that thing, that the 80,000 is connected with two data blocks adjacent, and these two data blocks are concurrently connecting to different IDs to locate that thing, that this particular 80,000 salary is available with two of the employees. First of the employee is, for example, Singh, and the second employee is Kim. Okay, so secondary indexes is sometimes quite important whenever you don't have some exact matching. Meaning is that if you are maintaining your maintaining your index file depend on some particular attributes, and your database is already sorted depend on some another attributes, then how you can fetch these things. So for this kind of fetching you need some another indexes which are taken care about the ID number and as well as the salary information. Okay, obviously it's required quite great overhead over the primary indexes. So index record point to the bucket that contains the pointer obviously to all the actual record with the particular such key values. Okay, secondary indexes have to be dense. Secondary indexes have to be dense in order. Okay. So next one is your multi-level indexing concept. So in multi-level indexing concept, we are maintaining some different level is there, means like the primary indexes, like the secondary indexes. In some cases we may take help from the tertiary indexes as well. So for that purpose we are going to discuss about the multi-level indexes, and that is our topic for today. If index does not fit in a memory, access become expensive. Obviously, if your indexing does not fit in your memory, then the access time will be quite higher. For example, in your previous example, if you are checking that thing, that if you are searching for starting from the index file that is salary 40,000, if you are searching this value in this result, then first you check first record, then second record, then you got your values at the third record. But after that you have to check that thing that another entries should not be present in this database with the same salary that is 40,000. Okay, so in case of primary indexes there are some kind of difficulties is there when the database ordered, means database order, the sorting order as well as the sequence as well as the index sorting order is not like same, or the attribute type is quite different. So for that purpose sometime multi-level indexing concept is quite helpful. Okay, so it reduces the cost of the query as well as it reduces the cost of the access time in case of a multi-level indexing. So solution is that treat the index kept on disk as a sequential file and construct a sparse index on it. Okay, and then we generate some outer index and the inner index concept. So here is the concept that is your outer index and that is your inner index, like this example, primary index, secondary index, then the database. So here in multi-level indexing the concept is there, outer index is there and inner indexing is there. Meaning is that in outer indexes some search key or search values are there, and each of the pointer locate to the inner index for this particular search key, and in this inner index you are finding this particular search key, match the search key, then depending on the pointer you redirect it to the exact data block. Got my point? Meaning is that, for example, here your outer index hold the information salary 40,000. This 40,000 is mapping to the secondary indexes, that with the 40,000 how many datas are there. The secondary indexes face that thing, total 2 records are there with the 40,000 indexes. First one is present at the data block 0 and second one is present at the data block 1. So for this kind of a purposes we are using the multi-level indexing concept. So this multi-level indexing concept can be extended using the outer, inner, more outer indexes and more inner indexes. Our memory parts are holding this information for that purposes. Next one is that we are using, so in this previous example you can check that thing, that the outer level indexes that holds the information, some raw information is there, for example the exact search key information is there or the salary information is there, and only one pointer link is there. But in secondary indexes you can check that thing, that the block holds the result, the blocks, the whole secondary index block hold the records that relate to the first index only. Meaning is that in your first index if you mention that department name is computer science and engineering, so here in the secondary blocks all the fields are there that is related to the information to the computer science department only, not any other department. Means from this particular outer index you are redirect to individual department, and within this individual department you are finding some faculty name, and from this faculty name information you are redirect to a particular faculty information in the data block scenarios. That is the situation of the multi-level indexing concept. Okay, so here some searching key methods are there, some composite searching key methods are there. Okay, so composite searching key methods is there, meaning is that index and, for example, instructor relation is there, 2 attributes are present, name and ID. Okay, so using this name and ID information you can face that thing, that here one name is John but the ID number is 12121, another person name is John but the ID number is 13514, like this. Okay, you can query through name only, but you have to check name and ID both combination in next step to fetch that thing. Okay, so next is your B plus tree concept. In B plus tree concept, Srilekha ma'am will already taken care of that thing, and I hope that very few part is there in the B plus tree concept, and this thing will be taken care of by the Srilekha ma'am. So for your beneficiary I am just giving you some example here that is helpful for the multi-level indexing, that in the primary node here you can check that thing according to the B plus tree. In the primary node some information is there. For example, if your first key value is Mozart, meaning is that all the information, all the person name that is less than Mozart according to the alphabetical order, means according to the MOZART, according to the Mozart whose name are less than in the periodical order of the Mozart, all the names should be present in the left side. Okay, and in right side the name can be start from the name Mozart or some higher degrees of the name. Okay, here the same thing is maintained. So from the Mozart in the left side key the name is connected at Einstein and Gold, and same as for the Einstein, all the name that the particular key is linked, all the name should be less than the Einstein in compared to the alphabetical order. Okay, so the same thing is maintained here and the same thing is maintained here. So that is the B plus tree structure. So here in this B plus tree structure, the first node is considered as the parent node or the root node, and all the intermediary node in between this label, means in the secondary label, that can be considered as the internal nodes, and all the ending results that are directly connected to the records, that is considered as the leaf nodes. So here the leaf nodes is connected with individual records, here the leaf node is connected with the individual records, means in your database, this is your database, and all these are considered as your multi-level indexes. So in this multi-level indexes, total 3 level is there. First level is starting from the Mozart, and the second level is left side of Mozart and right side of Mozart, and after that the sub part is that at the left side of Mozart there is some subsection, and from this subsection you can break that thing depend on your scenarios. Okay, so here different hierarchies are maintained in this B plus tree. So B plus tree is a good example of the order indexes concept or the multi-level indexing concept. That is the example of the B plus tree. So here in this B plus tree, some basics footnotes are there. In B plus tree, rooted nodes satisfy the following properties must be that all the path from the root to left are same length. Obviously, same length should be there. Each of the node that is not a root node must have or a leaf. If a node that is not a root node or not a leaf node, at least has between n by 2 or n number of children, means each of the node must have n number of children or n by 2 number of children if it is not the leaf node or the root node. Okay, so a leaf node has between n minus 1 divided by 2 or n minus 1 values, means a leaf node may carry n minus 2 or n minus 1 values. Okay, so in special cases where the root node is not a leaf node, it has at least two children, means in B plus tree if the root node is not considered as the leaf node, then it must have at least 2 children. Okay, if the root is a leaf node, so in that case it may hold some 0 child node or it may hold n minus 1 child node. That is dependent on the scenarios. Okay, so here the structure is there starting from the P1, means the value is there, and after that the related key values is there. So P1 K1, P2 K2 dot Pn minus 1, Kn minus 1, and ending with the last value that is connected to the ground. That's why it's not related to connect with any key, that is Pn. So Ki is your search key values and PIR is your pointer to the children. Okay, so all the search key values that should be less than in the order K1 less than K2 less than K3 dot Kn minus 1. Okay, so here is the things is that next one is your leaf node. Okay, some leaf node concept is there, that how leaf nodes are connected here. So in leaf node, all the leaf nodes are connected here depending on some search key values. First brand is connected here with the ID number 8381, Califree is connected here, Creek is connected here, like that. Okay, so here the concept is quite similar. So using this pointer you can connect the search values. Okay, so for the pointer 1 to dot n minus 1, pointer pi point to the file records with the search key values, and for the leaf node that is LILJ or for leaf node, and that is connected in a particular order. Okay, that thing will be better taken care of by Silica ma'am, because lots of examples are related to this part, some insertion and deletion part is there. Okay, so from my end these are the ending of the database management system syllabus for your beneficiary. Once I am recapping that thing, that in your starting part some basic structure of the database management system is there, history of the DBMS is there, some concepts of the degree of the relationship, lots of concepts are there. Okay, what is database management system, how management system is connected, what is view, what is table, this kind of information is there, why it is required. And in second module we already discussed about the ER diagram or the entity relationship diagram. In ER diagram or the entity relationship diagram, there is a vast concept about the attributes, fields, relationship, degree of the relationship. Okay, some kind of a concept about the specialization, generalization. Okay, weak entity set, different kind of a concept is there. So in third part we are basically focusing on the relational databases. In relational databases we are taking care about some concept about that tuple calculus, relational calculus, theoretical aspects of your SQL queries, this kind of things are there. Okay, and in fourth part we are focusing on the SQL. Okay, in SQL there is a concept about all the SQL commands, select, okay, DDL command, DML command, all the basic kinds of commands are there. Okay, we already covered that kind of a thing. And in fifth module we are focusing on the normalization part, that is quite helpful for our functional dependencies, data aggregation, this kind of a concept is there, functional dependencies are there, normalization concept is there, BCNF, 1NF, 3NF. Okay, this kind of concept is there. And after that in sixth chapter, that is quite helpful for the transaction management system, some views concept are there, some concurrency control is there, some transaction management is there, some log based concept is there, shared log based concept is there. Moreover, all the basic things related to the transaction managements that are present in this particular module. And in the last module I already discussed that thing. There is a very simple topics about the file and the indexing. Files are quite similar in your C language, in your data structure, in your operating system, as well as in your database management system. You can read these things from anywhere. Okay, so in file part we already taken care about the file, fixed length structure, variable length structure. After that indexing concept is there, some order indexes, sparse index, dense index, some multi-level indexing concept, and after that some example about the B tree and B plus tree. That is the whole about all your syllabuses, and we already covered the syllabuses and we explain these things. Okay, so tomorrow classes will be taken care by Momita ma'am, and after that your Wednesday classes, 2 classes are there by Srilekha ma'am. Ma'am will taken care about the some pending examples part. Ma'am is already covered B tree and B plus tree, and some pending example part will be covered in Wednesday classes. Okay, so from our end, so this thing is already covered and all the topics has been covered. Okay, I will share this lecture notes for the last module, that is the module number 7, means file and indexing part. Today I will share all the lecture notes and the related presentation and slides. Okay, and hope it is useful for everyone. So best of luck for your upcoming examination. Thank you for being. And now I am opening your quiz module. Okay, you put your quiz. Okay, and if you have any queries, just directly send me the queries in my WhatsApp number or in my email. Okay, I will explain each and everything, those who are feeling. Okay, now I am opening your quiz module. So all of you are requested to complete the quiz within 2 p.m. only. Okay, within 2 p.m. complete your quiz. After that the link will be locked. Okay, if you have any queries, send me. I will explain each and everything. Otherwise I can sign off here. Okay, complete your quiz within time. If you have any queries, just send me directly. Thank you. Thanks for viewing.